Hi, I'm Dori Segev. I'm one of the transplant surgeons and also biostatistician epidemiologist at Johns Hopkins. And this is a webinar where we're going to drill down into the estimated survival worksheets that the SRTR provides that will help you understand the risks that your center takes in terms of the program-specific reports and what patient phenotypes you have better outcomes for and what patient phenotypes you have worse outcomes for. So the main motivation for this is that all centers are at risk of getting flagged by the SRTR, by the program-specific reports, by CMS, etc. And it's important to understand how that works and what patients specifically at your center are having the worst outcomes. And the inclination is to say, okay, well, we're at risk of getting flagged, so what we're going to do is we're just going to stop doing ECDs. And if we stop doing ECDs, we're taking on less risk and our outcomes are going to improve, and then we're not going to be at risk of getting flagged. And that's actually not true. And I hope that by the end of this webinar, you will understand why that's actually not true, and you will understand what it is that you do take risks with and what it is that you don't take risks with. So I'm showing you a slide here from SRTR's standard slide set, which you can download from their website, talking about ECD kidneys. And the question posed on this slide is, will accepting ECD donors adversely affect center survival statistics? And this slide is an example from the kidney models, obviously. And so the things that are important to know from the risk adjustment models is that hypertension in the donor is accounted for, and you get a credit of 14% increased risk by using a donor that's hypertensive. Terminal creatinine is accounted for, again, with a hazard ratio of 6% higher risk for every 0.5 milligrams per deciliter of creatinine. Donor age is accounted for. Age over 65 is worth 1.71 further hazard adjustment. Cause of death is accounted for. And then even on top of that, the ECD classification itself is also accounted for. So with all of those things that make ECDs get adjusted in the risk adjustment models. There is another webinar that talks about how those risk adjustment methods work, and I will refer you to that for those details. What's interesting is that here is the example of excluding ECDs at various transplant centers. Okay, so if you look at all transplant centers, the failures per transplant of SCDs is 0.06, and the failures per transplant of ECDs is 0.15. If you look at a given example center here, this center actually has 0.09 failures per transplant for SCDs and 0.03 failures per transplant for ECDs. So if you look, they actually do better in their ECDs than the national average does, and they do worse in their SCDs than the national average does. And if this center were to stop doing ECDs, they would actually have a much worse outcome as far as the program-specific reports are concerned. And when Bridget Sullivan gives you the details of how those things work, you'll be able to see for your own center how you can examine that. How many kidney transplant programs have better outcomes for ECD than SCD? So the SRTR did this study. They looked at 206 kidney transplant programs that performed at least one transplant between 2005 and 2007. 109 programs benefited, similar to this example center that we showed on the previous slide regarding one-year graft survival. What that means is there were 109 programs where if they stopped doing ECDs, their numbers would actually look worse rather than looking better. I'm reminding you of something that we talked about in detail in the risk adjustment webinar, but that the three criteria that you need to meet to get flagged are that the observed minus expected has to exceed 3, that the proportion has to exceed 1.5, so the ratio has to exceed 1.5, and that the one-sided p-value has to be statistically significant, which means less than 0.05. And that's when flagging happens. The question is, how many centers get flagged for each of these criteria? And this is a graph where we see observed deaths on this axis and expected deaths on this axis. And each dot is a center. So this center had this number of expected deaths, around 9 point something, and observed 5 expected deaths, etc. And the line here is the similar, equal observed to expected performance. So you see there are a bunch of centers that have fewer deaths than expected and a bunch of centers that have more deaths than expected. But if you draw the line here and you create that, it has to be more than 3 excessive deaths. So there's that one criteria where they have to be, the O minus E has to be greater than 3. Now this is the new line here. So all of these, between these lines, they had more, but they didn't have enough more to be worrisome. And then we're left with all of these centers here that have more than 3 of the excessive deaths. And then we draw the 1.5 line, where you not only have to have more than 3, but you have to have 50% higher number. And so now everything that's only above both of these lines counts as that. And then we draw this statistically significant number. And so really the only centers getting flagged now, even though as we saw at the beginning, there were a bunch of centers that had more deaths than expected, the only ones getting flagged are the ones that meet all of these 3 criteria, and it's a handful of these centers here, and it's usually around 10% of centers that get flagged. And so this just shows here that as you watch where you go in terms of observed to expected, you can sort of guess where your trajectory will go. So here's a center that in 2004 met the greater than 3 criteria, just barely, but didn't meet the other ones, so they didn't get flagged. But they were above this white line. This white line is sort of the line of worry. And you see here in 06, July 06, they were creeping up toward not only being above the blue line, but they were almost above the pink and yellow line. And then the next year they went above both of those lines, and that's when they started getting flagged. So if you were to use the retrospectoscope and go back, you would have probably predicted that at some point this center was going to get flagged, because there were outcomes that were consistently meeting one of the criteria, but not necessarily all of them. Again, I showed this in the webinar where we went through the risk adjustment. The reminder is that the expected values for centers vary widely depending on the phenotype of patients being transplanted and the phenotype of donors being used. And we'll see that as we dive into the survival worksheets. And this, again, is just a reminder that about 10% of centers get flagged in any particular PSR cycle. Bridget Sullivan is going to show you how to go onto the web and download your particular center's expected survival worksheet, and then we're going to work with that worksheet.
Hello, I'm Bridget Sullivan. I'm the Administrative Director of the Johns Hopkins Transplant Center. And today I'm going to show you the SRTR website, where we can download some of the tools that Dr. Segev's been discussing today. So here I am. I'm on the SRTR website, and I have gotten into the archived section so that I can look at reports that have been published in July of 2012. And I'm here looking at my kidney transplant program. So first, what I will do is I'm going to look at what data may be missing from the spreadsheets that the SRTR uses to calculate our survival statistics. And this is really important because you need to ensure that all of your data is reported in order for it to be considered in what is used to calculate these statistics. So there's a spreadsheet here that you'll see. It's called SRTR Report Summary of Missing Data. And I'm just going to go ahead and download that. It's simple, just click by clicking on it. And I will open it. So here's the spreadsheet, and if I want to look and see what data may not have been reported yet before they actually run our survival statistics, I'm going to go into the spreadsheets. I'm going to look at our 1-year data. I can see here, for example, in the recipient height field, we are missing some data. So in this situation, I can actually go into UNet. I can open up the forms for these patients, and I can complete the data. And as I said, it's important to do this because all of these columns that are in here are factors that are going to be used in calculating our expected survival rates. Okay. The other thing that's on this website is the master spreadsheet that is published after the survival data has been calculated. And that is down here. It's this SRTR report, expected survival tables. You see for kidney, there's one for patients who've received living donor transplants, and then there's one for patients that have received deceased donor transplants. And so again, I'm just going to go ahead and download those. And then we are going to look at that in more detail after Dr. Segev speaks. The other thing that I want to show you today is how to identify what patients are used in the various cohorts that are being included for the SRTR reporting periods. And I do that by going into UNet. So now I've logged into UNet. This is my UNet site. And if I want to look at what patients are included in my SRTR report for July of 2012, I can run into tie-dye. And when that opens, I can go into Manage Data and then Search. And I can search on records within here. I can select the type of organ. In this case, I'm going to select kidney. I can select the type of record. I'm going to select just completed records. And then I can add additional search criteria to look at the month and the year of the cohort that I want to search on. So for July of 2012, I want to look at my 1-year survival. I'm going to look at patients that were transplanted between January 2009 and June 2011. And so I can put here January 2009. I can tell it to print 5,000 records a page so I can see everything, and then I will go ahead and search. I can go into each individual record and I can look at what fields may be missing. I can update that information and revalidate it. I can also make sure that the information that was reported when the form was originally done is accurate and has the most accurate information that's going to end up being used to calculate my expected survival.
So I've opened up here an expected survival worksheet, and I'm just going to take you through these tabs before Bridget takes you through the details. So the first tab is just the instructions, and it's important to read these through as you mess around with these worksheets because there's a lot of information here. Then you get a bunch of tabs, and these are sorted by the outcome. And this is the deceased donor graft survival 1 year after transplant, adult, and then this is the time period that we're seeing here. And so this is the 1 year graft survival. This is the thing that we worry about, right? And so what we've done here is we've shown you all the details. This is what the actual spreadsheet looks like. We've blanked out all of the identifiers here. And you can see patient by patient. Each row is a patient. And you can see all of the characteristics of the patients. If we scroll around here, these are all of the variables that go into the model. And you see the values for each of your patients. And then if you scroll down here, you see all of the patients that you transplanted during that time period. One page, one tab away from that is the entire, let's zoom in on this a little bit, the entire model that is used. Now you can find that model on the SRTR's website as well, but this is the whole model that's used. You get all of the variables that they account for, all of the hazard ratios, and these automatically calculate, as these data change, the important parts of the SRTR report, and that is the observed minus expected. Remember, once this gets beyond 3, that's when we worry. The observed divided by expected, once that gets beyond 1.5, that's when we worry. And then the p-value, once that gets below 0.05, that's when we worry. And if we change any of these things, so this is an event here. This means that the patient actually lost the graft. If we go and we change this to 0, you see that it updates these fields here. And so if this was an error, you would know how that would affect your outcomes. And so I'm going to put that back at 1. And what Bridget's going to do is she's going to show you how you can turn off or on different patient phenotypes to see how you do with different types of patients.
Okay, now we're going to look at the actual spreadsheet that is used to calculate our actual and expected survival. This is the spreadsheet for our program's 1 year deceased donor kidney transplant recipient survival. Up here at the top, we have the statistical tests that are used by CMS. And you can see here, this is our entire cohort for the time period. There were 310 transplants. The expected survival was 91.65. The expected number of graft failures was 23.81. Our actual or observed survival was 92.96, and our actual number of graft failures was 20. So over here we can see the statistical tests that CMS uses to look at whether or not we are above or below the expected survival rates. And our one-sided p-value is 0.255, which is fine because it's greater than 0.05. Our observed divided by expected is 0.84, which is also fine because it's less than 1.5. And our observed minus expected is negative 3.81, which is great because it's definitely below 3. So what I like to do before I start manipulating any of the data in the spreadsheet is I like to take this top results of our entire cohort and I like to copy it and paste it into a spreadsheet. So now I have just that bit of information pasted, and I'm going to now look at some different scenarios and compare them to our entire cohort. So over here in the far left column, there's a column called Include This Patient. And if this column has a 1 in it, then it means that it will include the patient that's in this row. Every single one of these rows is a patient. And in here is just a really simple formula. So I can adjust this formula to have it include or exclude certain patients. So in this case, if I wanted to look at how removing or isolating a certain population within my data set affects our expected survival, I can do that by changing this to a 1 or nothing in that column. I'm going to look at PRA, high PRA or highly sensitized patients, and see if I decided to reduce the number of highly sensitized patients that we are transplanting, how will that affect our survival rates? So I'm going to change the formula here. So it's an if-then formula. Go over here, there's PRA as a field. Okay, if the PRA is, and let's say if it's greater than 90, because that would be a very high PRA, then make the value in this field a 1, and if it's not, just don't put anything in that field. And then I'm going to apply that formula to the whole column, and you can see that several of the patients now don't have anything in that column. And up here you can see that now my results only include those patients that have a PRA of greater than 90. And that's 32 of my 310 transplants. And I can see over here that although my observed survival went down, my expected survival also went down. And so over here, when I look at the CMS tests, they're also still green, meaning they're also still acceptable. So I can see that even my highly sensitized patients, even though they don't have as high a survival rate as my whole cohort, they are high enough to be within that expected range and still be statistically okay. So if I wanted to change my outcomes, removing those patients from them would not be beneficial to our overall survival rate. Now I'm going to go ahead and just copy the results from that and paste it into my summary spreadsheet. And now we can see here, there's my original cohort. Now I'm looking at my high PRA patients. And I can label that. Okay, and then I can go back and I can do whatever scenario I like. Okay, now I'm going to show you something with a little bit more complex of a formula. Let's look at 2 factors. So I'm going to look at patients who had a donor from a DCD donor as well as an import. So DCD import, and let's see what that looks like. So I'm going to say that the DCD plus shared or import Okay, so I have 37 transplants in that cohort, and you can see here that we actually do really well with DCD imports. We can see that our observed survival is 94.59, which is actually higher than our original survival for the whole cohort. And our expected survival has gone down to 89.37. So when you look at our observed divided by expected rate, it's only 0.54, which means that we're actually benefiting our expected survival by transplanting these types of organs. So again, if I paste that into my scenarios sheet here, and we can see over here how these different groups of patients impact our expected survival. So how do we use these tools from the SRTR kind of in practice? Well, every few months before we know the next SRTR report is going to be generated, we will look at the missing data report and ensure that everything that can possibly be completed has been completed. We look at areas that have been weighted heavily previously in other expected calculations from previous SRTR reports and make sure that those are accurate for our patients. And we focus on those first. And then once the SRTR reports are published and the survival statistics spreadsheets come out that we can manipulate, we'll sit down with our program medical directors and we will look at the various types of cohorts that we just did. And if we identify patients that fall out as having a particularly low survival compared to expected, then we may decide to have a quality improvement initiative around understanding that variance better. It may not be something where we automatically stop transplanting those patients or using those donors, but we will put some thoughtful energy into figuring out how that population impacts our survival and where we may need to make some changes. So I hope that this has been helpful for you today, and I know that using these tools for me and for our program has been extremely helpful.